So, dear students, we are into testing. What are we into? Testing. Testing of apparels, testing of wovens, testing of knitting, testing of apparels, testing of knitting fabrics, knitted fabrics, testing of woven fabrics, and various topics we have covered in the first class. Now we will go to the second class of testing. So far we have covered in the 18 19 topics, 19 YouTube lessons. This is the 21st, I guess. So we have studied about raw material inspection, in process inspection, and final inspection. I have been saying it so many times. It is like proving myself. I told this classes, I told this. So something like that. Anyway, I took these classes or something like that. So in the previous class we have studied about standard test methods. Now we will study 5.2 and 5.3. I hope I will complete in this 40 minutes, and if possible we complete 5.4 also. Otherwise, let's see. Performance standards. 5.2 performance standards. 5.3 atmospheric conditions for testing. When it comes to performance standards or specifications, it is up to the buyer and seller to mutually arrive at performance specifications for various properties of an end item under consideration. Here garment, end item is garment. The ASTM Committee D13.56 on performance standards for textile fabrics has developed fabric performance specifications for various properties of various end items. These same performance specifications also cite the test procedures to be used in testing those items. These same performance specifications also cite the test procedures to be used in testing those items. A listing of these specifications is in Chapter 7 on standards and specifications. A buyer and seller may rely on these performance specifications and reference them in their contract. Refer them, give reference. This English is not correct. Some large buying houses, retailers, and government agencies have their own standards for various clothing items, and also the test methods to be used are advised by them. Some examples of such fabric performance specifications and test methods used by some large clothing manufacturers and retailers are also shown in the chapter 7 on standards and specifications. What I want to do is I just want to go to chapter 7. Why is he saying all these things in chapter 5? Everything is there in chapter 7, then why did you write all these things in chapter 5? Anyway, I will go to chapter 7 today itself. I will see. First I will read this complete performance standards 5.2. Whenever such clear-cut guidelines are not available, the interpretation of test results could be used on comparative data or past experience. And sometimes it is matter of intuitive judgment. In spite of all the standard test methods and available test data, the interpretation of test results is not exactly a science. I am not able to concentrate. So whenever such clear-cut guidelines are not available, the interpretation of test results could be based on comparative data or past experience. and sometimes it is a matter of intuitive judgment. In spite of all the standard test methods and available test data, the interpretation of test results is not exactly a science but sometimes a quality decision, though backed by though backed by numbers is a gut decision. The interpretation of test results must be done with particular care, and that's where expertise, that is technical knowledge combined with experience, comes into play. For example, color will rub off crocking from classical denim, twill cotton fabric dyed with indigo, because of the nature of the dyeing process in which a certain amount of dye is oxidized on the surface of the fabrics. Most denims would therefore fail both wet and dry rubbing tests before washing. To reject denim jeans for this reason would be unreasonable and would result in not being able to offer denim jeans to your customers. The integration of an individual's analytical abilities, technical skills, knowledge of industry processes, materials used, experience, intuition interprets and transforms data or test results into something far more valuable information, insight. The true value of quality of professional is to be able to make something out of data and create information to guide decision making. Very good. Performance standards. So in the whole this topic he has just talked about. Quality inspector should have expertise in experience. So that's what he says. The integration of a quality inspector's analytical abilities, technical skills. So analytical abilities, technical skills, knowledge of industry processes, raw materials used, experience, intuition. With all these things, the testing results should be analyzed and he should take a decision, and he should analyze the data and take a decision, and that is what decision making is based on. So performance standards is largely a theoretical subject here. So what does it mean? So generally most sellers and buyers will have specifications of ASTM standards or something like that. Sellers and buyers should have an agreement between the in mutual agreement should be there. A contract should be signed on. So what should be the acceptable standards are, and some large buying houses. This is for general sellers and buyers, and for large buying houses. So what is a large buying house? Suppose Coca-Cola is there. It's a big company, brand throughout the world it is there. So such are, if you come to textile industry, Levi's, that's a large worldwide company. So that buying house may have not just ASTM standards, it may have its own standards. So it is the buyer or seller or whatever it may be. So the suppose Levi's company is there and it is dealing with some testing of denims or something, then it will have its own standards and a contract should be signed by the seller and buyer on the performance of the standard testing procedures and results of the standard testing procedures and all these things. So that's what he is saying, some large buying houses. And one more thing is Government agencies. This is one more important factor I want to tell you. One of my professor in America, he used to be work for army, and I used to work under him as a research assistant. And government agencies will have different standards, so their standards are different. Their testing for textile industry, for government agencies, so the standards will be different, and they will have their own standards for clothing items. So that is what it is. So government agencies, large buying houses, retailers will have their own performance standards. So this is what it is. Defense, army, defense, navy, all these government agencies will have police inspectors, police dresses. So those will have different kinds of standards. So I am a little bit perturbed by this author's 7, chapter 7. I will go to chapter 7, standards and organization. So we have chapter 7 talks about different standards. So the whole book is about standards. The whole chapter is about standards. So you can I will show you. Why should you worry? So you see here. Why are you scanning? Who asked you to scan? Oh, okay. This is a better way. Whether it is scanning or whatever it is. So you see ASTM numbers. So this is about standards and specifications chapter. So I have gone through. So now my tension is relieved. What he talked about performance standards. So what is important? Quality inspectors intuition, not intuition. Intuition is also okay. Expertise and analytical abilities, technical skills, knowledge of industry processes, technical skills. So many things are important. So technical skills, knowledge of industry processes, analytical abilities, raw materials used. All these things should be taken into account before coming to a conclusion about a standard testing procedure. Even if it is done properly, at the end it depends on the expertise and experience of the quality inspector to decide about whether to go for the test fabric or not to go for the fabric, whether to accept the lot or reject the lot. So this is what it is. So you might have understood. So what is more important? Expertise. So that's one word. So next, atmospheric conditions for testing. Most textile fibers are hygroscopic, that is, they have the ability to absorb or give up moisture. This moisture is picked up or absorbed by hygroscopic material from the atmosphere if the relative amount of moisture in the air is greater than that in the materials. read like that, earlier like that. So it will be very very neat and nice. Most textile fibers are hygroscopic, that is, they have the ability to absorb or give up moisture. This moisture is picked up or absorbed by hygroscopic material from the atmosphere if the relative amount of moisture in the air is greater than that in the material. Conversely, the moisture will be given up by the material if the relative amount of moisture in the air is less than that in the material. Under natural conditions, the amount of moisture in the air is continuously changing. This results in varying the amount of moisture contained by a hygroscopic material exposed to the atmosphere, which will lead to a change in the physical properties of this material. For example, cotton absorbs moisture rapidly when exposed to high humidity. As a result, weight and strength of cotton increase while other properties change. Cellulose-based man-made fibers generally show reductions strength with corresponding increase in elongation as their moisture contents are increased. Wool fibers show a slight decrease in strength with an increase in moisture content. Practically speaking, all textile materials show increased pliability and reduced influence of static electricity with an increase in moisture content. Oh my god. Practically speaking, all textile materials show increased pliability and reduced influence of static electricity with an increase in moisture content. Therefore, in order to make reliable comparisons among different textile materials products among different laboratories, it is necessary to standardize the humidity and temperature conditions to which the textile material or product is subjected priority during testing. English is wrong, I don't know, stupid people. Is subjected prior to testing. Such conditions are 65 plus or minus 2% relative humidity RH and 21 plus or minus 1 degree centigrade or 70 degrees plus or minus 2 degrees Fahrenheit. The test samples should be left in a conditioning room. The test samples fabrics or garments should be left in conditioning room with the above atmospheric condition for at least 4 hours to reach equilibrium with the standard relative humidity and temperature. Then they should be tested under the same atmospheric conditions. If the test is not done at standard atmospheric conditions, then this must be stated clearly in the test report along with the relative humidity and temperature at which the testing had been done. ASTM D1776 Standard Practice for Conditioning Textiles for Testing, Annual Book of ASTM Standards, Volume 0.7.1, 0.07.01 covers how to condition specimens for testing. Okay. The heading should be standard atmospheric conditions for testing, not atmospheric conditions for testing. So 5.3 is, you see, 5.3. So 5.3 is atmospheric conditions for testing, but the heading should be standard atmospheric conditions for testing. So why standard atmospheric conditions for testing are being brought into picture? So this is very simple topic, at the same time very important. If you don't if you underestimate it, it will be problematic, so please understand it. Most cotton fibers are hygroscopic: wool hygroscopic, polyester not hygroscopic. So why standard testing, why standard atmospheric conditions have been developed by the standard companies, ASTM standards or AATC standards, is if you leave a cotton or wool or polyester fabric or garment in a normal atmosphere, then it will either absorb moisture from the air or desorb moisture from the air, depending on the situation. It may absorb the moisture from the air, or it may desorb from the moisture from the air. So if you test, so this itself indicates that atmospheric conditions vary. Atmospheric conditions in a house are different. Atmospheric conditions in one lab is different and in another lab is different, and atmospheric conditions are vary depending on the environment. So that's why it propelled the standard ASTM standards companies and other companies to find out standard atmospheric conditions of testing, because so that standard atmospheric conditions are present for testing throughout the world. So these are the standard atmospheric conditions throughout the world. I mean, it may vary depending on whether it is spinning department or weaving department or like something like that, but such conditions are generally standard atmospheric conditions. Means temperature and relative humidity, both of them are taken into account. So relative humidity is 65 plus or minus 2%, and temperature is 21 degrees plus or minus 1%. So these are the standard atmospheric conditions. So under natural conditions should not be present. So it may, sometimes there will be sunlight, sometimes there will be rain, sometimes humidity will be more, sometimes humidity will be less, sometimes temperature will be more, sometimes temperature will be less. So if you conduct a tensile strength experiment, if without atmospheric conditions and testing, then it will be problematic. So that's why these standard atmospheric conditions were developed, and they are being used throughout the textile industry nowadays. So that is about standard atmospheric conditions. So dear students, we have studied about performance standards and atmospheric conditions for testing. So today 5.2, 5.3, and now we will go to fiber identification, 5.4. Qualitative ways of fiber identification are as follows. There are 5.4 is fiber identification. So here we have A to F, the topics. A is microscopic examination, B is solubility in a solvent, C is melting point, D is reaction to flame, E is density, F is refractive index, and all these things. So fiber identification, I think we can complete this also. Fiber identification, under that I will read one by one and explain. Microscopic examination. Typically, cross-section and longitudinal views of fibers under microscope are compared with reference standards. All textile fibers have their own peculiar cross-sections and longitudinal views. Therefore, by identifying these views, fibers can be identified. Considerable experience is necessary in using this method as fiber cross sections and longitudinal views vary a great deal. AATCC test method 20 fiber analysis qualitative has 124 reference photographs of cross section and longitudinal views of various fibers. Microscopic examination is particularly useful in characterizing the natural fibers. It must be used with caution on man-made fibers since they are frequently produced in a number of modifications which alter the longitudinal or cross-sectional appearance. So dear students, microscopic examination. What do you do with microscopic examination? Of course, we will do cross-sectional and longitudinal view of the fibers. Of course, we will study cross-sectional view and longitudinal view study. So AATCC, American Association of Textile Chemists and Colorists, test method 20 fiber analysis. It has 124 reference photographs. So if you go to the test method, it has 124 reference photographs of cross section and longitudinal views of various fibers. And when you do microscopic examination in your company or in your lab, then in that case you have to compare your cross section with the reference with the 124 reference photograph, and then you can find out the cross sectional view. So that is about cross sectional views and longitudinal views using microscopic examination. And you can find out the fiber identify. You can identify the fiber. With that you can identify the fiber. What do you do with cross sectional and longitudinal view? You identify the fiber. So these are all come under fiber identification. Solubility in a solvent, B. So we have completed microscopic examination. Now we are in solubility in a solvent. Certain fibers are soluble in certain solvents. For example, cotton is soluble in sulfuric acid, but polyester is not. Wool is soluble in sodium hypochlorite, but cotton, polyester and nylon are not. So you can find out the fiber, you can identify the fiber by solubility test also. So if you have a cotton fiber, then you put it in a sulfuric acid. If it is soluble, it is cotton, and if it is not, and if you put it polyester, it is not soluble. So you can find out like that. Wool is soluble in sodium hypochlorite. So if you have wool, cotton, polyester and nylon fibers with you, and if you put the wool fiber in the hypochlorite, sodium hypochlorite solution, then if it is soluble, you can find out that it is wool fiber. Otherwise it is not wool fiber. So microscopic examination is completed and solubility in a solvent is completed. Next, melting point. Various fibers have various melting points. Melting point of polyester varies from 250 to 260 degrees centigrade, while nylon will melt at 213 213 to 225 degrees centigrade. I have told in the previous years to the students that find out the melting points of all the fibers and write down so that it will be useful for you throughout your textile industry. So various fibers have various melting points. So in the last year's class I have told people that find out the melting point of all the fibers. So polyester varies from 250 to polyester melting point is 250 to 260 degrees. Nylon is 213 to 225 degrees centigrade. So these are all why I am studying all these things because these are fiber identification methods. Next, reaction to flame. Various fibers react on exposure to a flame in different ways. Therefore, based on how they react to flame helps to identify a fiber. Polyester, nylon, mod acrylic and woolen fibers burn up while applying flame to them. However, they will self-extinguish when the flame is removed. Cellulose fiber will continue to burn rapidly even when flame is removed, while acetate fiber will continue to burn slowly. Cotton and rayon fibers produce same odor as of paper burning. So, by finding out the flame properties of fibers, also you can identify the fibers. So cotton cellulose fiber will continue to burn rapidly even after flame is removed, while acetate burns slowly even after the flame is removed. And cotton and rayon fibers produce same odor means smell as of paper burning. So cotton and rayon fibers will produce same smell as of paper burning. Now how smell is measured, you find out. You are the future of the textile industry. So maybe there are some ASTM standards, nobody knows. So what he says, cotton and rayon fibers produce same odor as of paper burning. Same odor, who decides same odor? I say they are of same odor. And Rashmika will come and say, no sir, they are of different odor. So what is odor? How do you measure odor? Smell. So for that also there will be testings. Generally there will be some standard things available probably because technology is developed so much. But so if they are not there, you try to find out. So polyester, nylon and mod acrylic and woolen fibers burn up while however they will self in the flame. So this is about reaction to flame. After flame is removed, they will self extinguish. That means మంట చల్లారిపోతుంది. ఏ ఫైబర్స్కి? పాలిస్టర్, నైలాన్, మోడాక్రలిక్ అండ్ వులెన్ ఫైబర్స్. అంటించిన తర్వాత it will burn, but if you take out the flame they will stop burning. Whereas in cotton it will continue to burn rapidly means fast, whereas in acetate will burn slowly. So this is about reaction to flame. So density, now we are into density. Different fibers have different density. Therefore, by measuring density, a fiber can be identified. For example, density of cellulose fibers is 1.51 grams per cubic centimeter, while nylon's density is 1.1 to 1.15 grams per cubic centimeter. So densities of various fibers, you can, this is also another assignment for you. Find out the melting points. Last year also I have given to students. Find out the melting points of all the fibers. Find out the melting points of, find out the densities of all the fibers. And then if you know them perfectly, then you don't need to worry about throughout life. So once you studied something, it will be there in your mind forever. So densities of different fibers. So by testing the, by finding out the densities of various fibers, you can identify fibers, whether they are, it is a wool or nylon or cellulose fiber. And this is how fiber identification is done. So coming to refractive index. Refractive index of a medium is a measure of how much speed of light is reduced inside the medium. This is very important topic. Refractive index is, I told in the classes, previous classes also. The speed of light when it enters into medium, it reduces. So that is a measure of refractive index. So refractive indexes of various fibers vary a great deal. Therefore, by measuring refractive index of a fiber, it is possible to identify it. For example, refractive index of polyester is 1.71 to 1.73 longitudinally, 1.53 to 1.54 cross-sectionally, while silk's refractive index is 1.59 longitudinally and 1.54 cross-sectionally. So refractive index is a measure of how much the light of speed is reduced when the medium is present. Medium here is our fiber. If our fiber silk is present, then what is the speed of, how much speed of light is reduced? So that is, and if you measure that refractive index, it's a wonderful chapter in physics about refractive index, refraction and reflection and total internal reflection. All these topics are very dear to me sometimes and very obnoxious to me sometimes, because sometimes I get I understand them to a certain level, and after certain level I am not also able to understand what exactly is. So that's why I am not a big scientist or some big engineer or something like that. So refractive index is a very good topic. So anyway, that's a good thing. So dear students, today we have studied performance standards. So in the previous class and now present class, we have studied standard test methods, performance standards, atmospheric conditions for testing. And in the fiber identification, we have studied how fibers are identified. Fibers are identified by 6 methods. I give a 7th method, moisture. So book has given only 6 methods. I am giving one more, 7, moisture. So whatever. So what are the 6 methods? Microscopic examination, solubility in a solvent, melting point, reaction to flame, density, refractive index. So dear students, we have completed our class and in the next class we will